Today we're going to be talking about how do we use congruent triangles to prove segments and angles congruent. So let's take a look at this now. We're given the fact that these two triangles are congruent. Triangle ABC is congruent to triangle DEC. Name all the congruent sides and angles. So remember, the lettering that the triangles are in tells us which sides and angles correspond to one another. So because A and D come first in the ordering, we know that angle A is congruent to angle D. Similarly, angle B is congruent to angle E, and then my angles in the middle, angle ACB, is congruent to angle ECD. Now for the sides, it's pretty much the same thing. Use the lettering to help you. Because AB comes first, we know that AB is congruent to DE. Again, they're the first two letters in the lettering. AC is congruent to DC, and then finally, BC is congruent to EC. Now we have a theorem that allows us to say that all these parts are congruent because the triangles are congruent. This is called CPCTC, which stands for corresponding parts of congruent triangles are congruent. So when you use it in a proof, you can just use those 5 letters, kind of like we use ASA or SAS. You would use CPCTC if you wanted to prove that corresponding parts of congruent triangles are congruent. Now the thing though you have to remember is you still must prove that the triangles are congruent first. Once you prove the triangles are congruent, then you can use that to prove any piece of the triangles are congruent. So this is going to kind of be like an add-on to the proofs that we were doing last week. So let's do an example to show you. So given AB congruent to CD and BC congruent to DA. Let's write that down in our proof. AB congruent to CD, BC congruent to DA. Reason given. Now look at your proof line. This is something we haven't seen before. We're trying to prove angles, not triangles. When you see this, this is your clue that I'm going to be having to use CPCTC because they're parts of the triangle. But in order to do this, I'm first going to have to prove congruent triangles. And I like to name the triangles ahead of time just so I know. So I'm going to name them as triangle DAC and triangle BAC. Again, try to be careful with your lettering that the corresponding parts go together. So we're given 2 sides already. Here's a side, here's a side. Remember our different ways for proving triangles. SAS, SSS, ASA, AAS, HL. So we're already given 2 sides, okay? And I need a third piece. Any ideas of where that third piece is going to come from? We're out of given, so it can't be something they give us. So hopefully you said the reflexive side. That's going to be a third side. So I know I'm using SSS to prove the triangles. I really like to plan before I start writing the proof, so then all I really have to do is just put the steps into play. So I need to mention that third side. So it's going to be AC congruent to AC. Reason, the reflexive property. Okay, now I have all 3 sides in my proof already. So now I can prove the triangle's congruent. And I already wrote the names of the triangles. Triangle DAC congruent to triangle BAC. Reason, we already figured it out, SSS. Now this is what the new step looks like. Once you have the triangles proven congruent, your last step is your proof line, angle B congruent to angle D, and your reason, CPCTC, or corresponding parts of congruent triangles are congruent. Because the triangles are proven congruent in the previous step, now I know any side or any angle that's in the same spot are congruent, and B and D are in the same spot. Let's try another example. So given AEC and BFC intersect at C, angle 1 congruent to angle 2, let's mark it, CE congruent to CF, EA congruent to FB. Prove angle 3 congruent to angle 4. So again, I see that my prove line involves pieces. So right off the bat, that's going to tell us, okay, it's probably CPCTC. And I know I need congruent triangles. And what are those congruent triangles? Triangle CAD and triangle CBD. Again, I just like to have the plan in my head. So what was given to us? A bunch of pieces, right? AEC and BFC intersect at C. Angle 1 congruent to angle 2. CE congruent to CF. Lots of givens here. EA congruent to FB. Okay, phew, that's a lot of givens. All right. So I definitely see I have a side, right? I have this whole side and this whole side, but they gave it to us in pieces. So that signals in my head that I'm probably going to have to use addition in order to add those pieces together, but it's still a side. And they gave us an angle at the top. I'm out of givens. I have no keywords. So how am I going to get that third piece again in order to prove the triangle's congruent? So hopefully you notice again, we have that reflexive in play. So that's going to be our third piece. And then I know it's going to be SAS. So now we have our plan. Let's put it into motion. So remember I said before, they gave us the whole side, but they gave it to us in pieces. So we are going to have to add those pieces together to get the whole sides congruent. Now I want you to keep in mind, people do addition in many different ways. I'm going to show you the way that I do it, but it's very possible that your teacher might teach it in a slightly different way. So CE plus EA, those are the two pieces that make up CA, is congruent to CF plus FB, or CA is congruent to CB, the whole sides. The reason we can say this is addition property or postulate. Now keep in mind, the reason I was able to use addition is because I knew all of the smaller pieces were congruent, so they make up congruent wholes. Okay, so I got my whole sides. The angles were given to us. Now I have to mention my second side, which we already said was reflexive. CD congruent to CD, reflexive property. Okay, I got all my pieces for my triangles. I can say my triangles are congruent. Triangle CAD is congruent to triangle CBD. And we already said it was SAS. And then finally, angle 3 is congruent to angle 4. And the reason why? CPCTC. So I really think it's super important to have your plan before you start writing. I planned that I was going to use CPCTC. I planned the names of the triangles that I had to prove congruent. I planned addition and I planned SAS. That way when you go to write the proof, it's just a matter of putting the steps in the right order. And also keep in mind, these two steps could be reversed. Because a lot of kids always ask me, how do I know the order that you put them in? Sometimes order matters and sometimes it doesn't. For step 2 and 3, the order isn't so important, but both those steps have to happen before step 4 and 5. I'm going to give you guys a moment. Why don't you see if you could figure something out for this proof? See if you can determine the way that we're going to prove that BD bisects angle ABC. Keep that in mind. That's a different given than a different proof line than we've seen before. So think about what our last step might have to look like. So notice I'm not asked to prove pieces. I'm asked to prove that I have a bisector. That's different than I've ever seen before. But it helps if I know what a bisector is. They want me to prove that BD is bisecting angle ABC. That means I should have two congruent parts. Parts, which makes me think about CPCTC. So I'm still going to have to use CPCTC. It's just that I'm going to have to add one additional step to mention that I have a bisector at the end. Did anyone figure out what two triangles I need to prove congruent? Take a moment, see if you can figure out what the triangles are. So hopefully you looked at the givens, BA, BC, DA, and DC. The triangles that we're going to have to prove congruent are triangle BAD, triangle BAD, and triangle BCD. Okay, because those are the triangles that have the parts that I'm going to need congruent. Okay, and where are those parts? They're the parts of angle ABC. So they're going to be at B up here. Those are going to be the parts. Think for a moment, what method do you think we're going to be able to prove these triangles congruent by? So based on the givens, notice we have another reflexive, so we're going to be using SSS here. So we have our plan, now let's put it into motion. So starting with our givens. BA congruent to BC, DA congruent to DC. Step 2. Now remember, I can't mention parts or anything until I prove the triangle is congruent, and I already have two sides, so I'm just going to mention that third side. BD congruent to BD. Reason, reflexive property. Notice we use reflexive property a lot. It comes up a lot in triangle proofs. Okay, we have all our parts. Let's name the triangles congruent. Again, we already planned it. The reason is SSS. Now that I've proven the triangle's congruent, I can mention the pieces that I need that are congruent. So again, where are the pieces? They have to be part of angle ABC, so they're going to be up here. Angle ABD congruent to angle CBD. Reason? What's the reason that those pieces are congruent? Remember, we just proved triangles congruent. So hopefully you said CPCTC. Corresponding parts of congruent triangles are congruent. Now this is the step that's a little bit different that we haven't seen before. I've already proven the pieces. I'm ready to say my prove line. BD bisects angle ABC. Why? Well, keep in mind, I just proved that those two angles are congruent, and that's what a bisector does. So that's the reason that I have a bisector. If two parts of an angle are congruent, then the angle is being bisected. So again, that's my interpretation. Everybody writes proof slightly differently. Everyone uses slightly different words. So again, if you've seen this written slightly differently, that's okay. This is the way that I'm going to write it. One more example and then we're done. Given DC congruent to DE, angle X is here, congruent to angle Y, and angle Z congruent to angle W. Prove AE and AC are congruent. Why don't you guys take a moment, pause the video, see if you can write the full proof up. See if you can figure out what my last step's going to be, where my triangles are, what method of the triangle is congruent, and all that stuff. And we'll get started in just a minute. So, hopefully you noticed again that we're trying to prove pieces, so we know our last step is CPCTC. Where are the triangles that we want to prove congruent? Well, if you look at the pieces lend themselves to this triangle, triangle DCA, and this triangle, triangle DEA. Okay. Also notice that I was given smaller pieces, but I'm going to have to, again, add them together to get these bigger angles congruent, okay? Sometimes people get thrown off when there's a lot of triangles, but remember, the triangles that you're trying to prove congruent have to have the pieces that I'm trying to prove congruent in them, right? I can't prove one of these little baby triangles congruent because AE and AC are not in the baby triangles, they're in the big triangles. All right, so those are my triangles. What method do you think the triangles are going to be congruent by? Keep in mind, this is a side. These together make an angle, and then we're missing a third piece. So again, we're going to be using reflexive, and hopefully you notice the method we're using is SAS. Now let's write up the proof. DC congruent to DE, angle X congruent to angle Y, angle Z congruent to angle W. So I'm going to start by doing the addition postulate to add the angles together to get the congruent whole angle. Again, everybody writes addition a little bit differently, so if you've learned it slightly differently, I do apologize. This is the way that I write addition. So, angle X plus angle Z is congruent to angle Y plus angle W, or angle CDA is congruent to angle EDA. Addition postulate. Property. Okay, there's my angle. Third piece, again, is reflexive. They really like reflexive in these triangle proofs. Okay, now I have all my pieces. We can prove the triangle's congruent. Triangle CDA is congruent to triangle EDA. SAS. And finally, AE congruent to AC, CPCTC. So again, guys, keep in mind with CPCTC, the important thing is you must prove triangles congruent first. Use the pieces to help you figure out where the triangles are, and try to be careful when you do your lettering that the pieces match up and everything's in the right place. Hopefully you found this helpful.